Live streaming is a powerful tool for reaching audiences and sharing events in real time. However, there are a number of challenges associated with live streaming that can impact the quality and reliability of the video stream. One of the biggest challenges with live streaming is the variability of network conditions. Whether you're streaming from a remote location or a crowded event, network congestion can lead to buffering, stuttering, and dropped frames. This can be especially frustrating for viewers who expect a seamless and uninterrupted viewing experience. Another challenge with live streaming is the need for reliable and stable internet connectivity. Traditional Wi-Fi and cellular connections can be unreliable, with signal strength and bandwidth varying widely depending on location and network conditions. This can make it difficult to maintain a consistent and high-quality video stream. This is where LiveU Reliable Transport (LRT) comes in. What is LRT? LRT is a patented technology that addresses many of the challenges associated with live streaming. LRT is the video and audio delivery protocol developed over the last decade by LiveU, the inventor and patent holder of cellular bonding. The LRT protocol supports low latency, high resiliency video and audio transmission and was built from the ground up to accommodate the special properties of 4G, 5G cellular as well as more traditional wireless and wired networks. In particular, LRT is optimized to support the bonding of multiple IP connections. LiveU Reliable Transport (LRT) uses network bonding to aggregate multiple network connections and create a more robust and reliable internet connection. Network bonding allows LiveU solo devices to combine cellular and Wi-Fi connections to create a single, high-bandwidth connection that can support high-quality video transmission. This is achieved by splitting the video stream into smaller packets and transmitting them over multiple network connections simultaneously. The packets are then reassembled on the receiving end to create a seamless and uninterrupted video stream. In some situations, one or more of the individual network connections may become unstable or fail completely. This can happen due to factors such as network congestion, signal interference, or physical obstacles. LRT ensures if any of the connections becomes unstable, the bonded connection remains robust. The bonded connection acts as a virtual pipe that aggregates the bandwidth of all the individual connections. This allows the video stream to use the full available bandwidth and maintain a high quality and uninterrupted transmission even in challenging network conditions. LRT applies multiple resiliency transmission techniques simultaneously, such as packet ordering, dynamic forward error corrections, acknowledge and resend, and adaptive bitrate encoding. Packet ordering. In LRT, packets of data are split into smaller pieces and transmitted over multiple network connections simultaneously. However, due to variations in the quality and performance of different network connections, the packets may arrive at the receiving end out of order. To address this challenge, LRT uses advanced packet ordering algorithms that reassemble the packets in the correct order on the receiving end. These algorithms analyze the characteristics of each network connection, such as latency and bandwidth, to determine the optimal order in which to reassemble the packets. Acknowledge and resend. LRT can acknowledge large groups of packets if they all arrived. If some did not arrive, it can inform the streaming engine to resend needed data. By acknowledging large groups of packets at a time, LRT uses less overhead and latency. Unlike UDP, LRT gives complete feedback loop so the user knows that the data is arriving correctly. Dynamic Forward Error Correction (FEC). LRT also applies a technique called Dynamic Forward Error Correction to improve reliability and throughput. Briefly, forward error correction transmits a small amount of redundant data with the primary stream to enable the decoder to identify and resolve transmission errors and recover lost data faster without needing to retransmit any data. LRT automatically varies the FEC parameters based on monitored network conditions. Adaptive bitrate encoding. Here you see how it all works over time. During a live video stream, the bandwidth will fluctuate, depending upon where you are located if you're moving or just general cellular congestion. But LRT ensures that your video continues to stream by automatically adapting the video bitrate to accommodate these network fluctuations. This way your video continues to transmit at the highest possible quality at any given time. If the bandwidth lowers, LRT will lower the video bitrate to ensure the transmission is never dropped. When the bandwidth stabilizes, the bitrate will increase to the best possible quality without any action from you. Whether you're streaming to social networks or covering a large-scale broadcast, LiveU removes the need for expensive satellite connectivity, frees you from being hardwired to an internet connection, and allows you to go anywhere to share great quality live video with confidence. LiveU LRT is a cloud subscription service complementing the LiveU encoders. In our next video, we'll go through the subscription and setup of LiveU LRT service. Thanks for watching this video. Do remember to like this video and subscribe our channel to get instant updates on our new videos on live streaming and broadcasting technologies.
Elevate your live events with StreamPod streaming solutions. Webcasting, broadcasting, consultancy, India's one-stop shop for live events.